Welcome back to another day of 115. What we're going to be talking about today in particular is sort of all tying all of this crypto and actually really a lot of the semester together. So to do this, what we're going to be doing is using everything we've talked about and making this Music Rater app, but making a Music Rater app that we can actually have users for. So having people be able to log in and log out. So we'll go through that in a second. Before I start, I want to just give a little bit of time for if anybody wants. Just, I'm not sure. I think it's right about noon. Give people a couple minutes to connect, all that sort of stuff. One other thing, just because I know this decision happened to be made, I think yesterday. If anybody is thinking of taking 116 this summer, that certainly is an option. The instructor this summer is actually a graduate TA for me, just in a different course, not for 115, for a different course, for a grad level course I'm teaching. He's actually very, very good. I've seen him working with the master's students on their work. So I would definitely encourage you, if you're interested, to do that. Other than that, getting back to the project at hand. So one thing you'll see, and this is true always, is, there are a lot of files here, obviously. These projects, and over time, it's just been getting bigger and bigger and bigger, I realize, because that's how systems work, right? We never sit down and just write out everything at once. In fact, one of the big lessons that my students, the students in CSE 442, this is the software engineering class, it is the capstone class for the major. One of the big things that they learn is this process of taking a big project and dividing it into small pieces so that you can do it a little bit at a time. Another thing you can see is that, and I realize I tend to be on one end of this, but I'm very, very big on keeping everything really organized, neat, and clean. Now, if any of you saw my office back when I had an office, or honestly, if you could see the desk/work area I'm at right now, which is overflowing with stuff, you'd know I'm not a very organized person in my personal life by habit. But when it comes to code, it's really, really helpful. So part of what I've done right now is really split out my code into a couple of different folders. So I have this one folder, key files. That's where all the key files will be. And we're actually going to be using two sets of key files, one for encryption and one for what's called signing something. So we'll talk about that in a little bit. I've got this front end folder here, and this is where I keep all of the front end work. And so some of this is familiar, the ajax.js file, which honestly I just copy from REPL to REPL, right? That just has the Ajax GET request and POST request. That way I never have to think about it. HTML helpers, which I've been using in this music rating app that just contains the code for, frankly, for rating music, for creating the web pages that we need. But then what I've done, I renamed, I think it was my code before. We've got app.html, and this is going to be our main app page. You can see rate songs here. It's got, the add and the search. And that's going to use the file app.js. I renamed this slightly just because as we get now multiple HTML files, multiple purposes, it helps to be able to understand everything, to see where everything is. There's also index.html. And remember that in Replit with this bottle server, that's by default where we're going to start. And actually, that's the default file name that we're always going to be using. For that one, we're going to have to log in. So we're actually going to create a system now where we're going to make users log in. So when we start, and I can actually start this process right now. as it goes through and installs everything. And note that we've added that bcrypt library because we're going to have logins. So since we're going to have logins with that bcrypt library, we need to have a way of doing it. I'm going to open this in a new tab. Close this up because I don't like that tab. So you can see, maybe, eventually, hopefully. Well, you can see right here what this is looking like. I'm not sure why it's not loading up in that new tab. That's interesting that it's taking so long. But you can see that what we're going to have at the beginning is this window where we can register an account or we can log in with an account. And so I've actually already created an account at the beginning of our code in main. You can see that what I'm going to do is I'm actually going to create 2 sets of keys. So this is again using the same process as before. We're going to have 1 set of keys for encryption. So that way we can encrypt traffic back and forth, just keep things a little private, particularly because we're sending usernames and passwords, most importantly. Those passwords, there we go. So it just was being slow for some reason. So do that. Let me also open up the web developer because, this is useful. So the one account I have is for me. If I try to log in with another account, do it after my wife. I can type anything I want in here. You can see that it's going to come back with an error saying that that username is not registered. Now, one important thing to know if you're ever writing or when you're writing an application that takes in usernames and passwords, you actually never in real life want to have this error message. You should never tell people whether what usernames have and have not been registered, because by doing that, you actually leak a little bit of information. You make it easier to hack your system. On the other hand, if you're developing a system in 1.15, where the goal is letting students see what's going on, that's not a bad idea. So I'll actually log in with my account. I have a very secret password. And you can see when it shows up, it's telling me it doesn't like my font for some reason. But more importantly, right, we've got that same thing as before, but note that we start, it says welcome M Hertz. So let's see how this part of this works. So when we begin, we create our encryption keys. We're going to create signature keys. And because honestly, I was being lazy, normally we wouldn't want to keep these keys in memory, but I'm going to do that now. At the beginning, I just created this function to print out the result of the users table. So we're going to add to our database a users table. That users table is going to have usernames and passwords. So you can see here, I only have one registered user. The name is M Hertz, that's for me. And then this is not the password, but that password after it's been hashed. That is the hash result. So we're going to use salting and hashing on the password to keep it secure. And then we're going to run it. So when we start up, right, we get that route slash. We're going to have everything go to the front end. I've got my @bottle routes for JavaScript files and HTML files. And because I know I'm going to, at the point I have 2 files, 3 files, 4 files, I know I'm going to have more. So I just have anything matching .js handled by this one function and go to that front end folder. Eventually I might need to make it even fancier, but for the moment, that's enough. So that beginning page, right, that slash page would be the login page. And in the login page, if we look, what we can see is that it's got 2 buttons, login and register. And in security, we can see what we're going to do on the JavaScript side when we use them. So for the login function, what we're going to do, we're going to get the username, login username and password elements from the web page, get their values. And then we're just simply going to build an object. I'll have two keys, username and password. We'll turn that into a JSON blob. And then, and this is important, we're going to encrypt it. So we're not going to send our username and password in plain text. That would be, well, I say that would be foolish, and it would be foolish. It unfortunately happens fairly often. But that's obviously insecure. So what we're going to do is we will encrypt that, and then we will use a post request. We will send those encrypted credentials to a /login route. And when we're done, we're going to get this response display login. Now, display login itself is going to be relatively simple. What we're going to do is we're going to get the response. We're going to, parse that JSON blob, turn it into usable data in JavaScript. Now I'm going to use an object. It's going to have this key authenticated, and that result will tell us whether we were successful, whether we were able to log in. So when we were successful at logging in, what we need to do is, if you look, I'm at a different web page here, even though I never actually changed that URL. The trick is that JavaScript can do that, right? So by typing window.location.replace, this is a function built into JavaScript. It's part of that, similar to part of that DOM library, like with a document down here. We can also use window. It talks about the window. The location is the thing in the bar. And so when I say replace it with /app, that automatically redirects the web browser to load in that new page. If I were unsuccessful at logging in, instead what would happen is it would have a message, and we would simply display that message on the screen when the login wasn't successful. So what happens during that /login process? We can go over to main for that. And so you can see here what we're going to do. We're going to decode, we're going to get that JSON blob, and then just as before, we're going to decrypt it. We're going to use the PyCryptoDome libraries to decrypt that JSON blob so we get back to the original username and password. Then what we're going to do is call JSON loads. So now that it's decrypted, we can turn that JSON blob back into the original object, and we're going to attempt to log in. So in authentication, you can see there's a function here, login attempt. And so what that's going to do, it's going to create our response, our accumulator. We're going to say if the username does not already exist. And the way that username already exists works is it simply says, well, if the username is blank, obviously it doesn't exist. Otherwise, what we do is we do a selection from the users table. Just try to get that from the users table. And we see if the length is greater than 0. Is there a name? Is there a row with that username in our table, right? Select star from users table where username equals, and then we have a question mark because we're going to use the safe version. We certainly don't want to allow someone to hack in, especially when we're trying to start up. So if it doesn't already exist, then we create the message, username is not registered, and note that by default, authentication is false. If, and I have an elif here, so when that username already exists, then we'll call this authenticate function. And so what it's going to do is it's again going to get the row with that username. And after that, what it will do is it will use this bcrypt library, and it's going to check the password. And one of the benefits of the bcrypt library is that what we're going to have to give it is two things. One, this row index 1, this is going to be the actual hashed password, the actual thing that we saved. I think it's the second thing that we're going to do is we're going to take that password and we're going to encode it. This might sound like it's really fancy and doing all sorts of really tricky stuff. It's not. All that encode function does, remember the password is just going to be a string. All that encode function does is turns it into an array from a string, a str, to a list of bytes. So it turns it into a collection of bytes of those zeros and ones, actually 8 zeros and ones. A byte is 8 bits long. That's easier for the computer to use. And at that point, the bcrypt library has a function, checkpw, that will automatically salt and hash those bytes and see if it matches what we saved. If that result, when that result comes back, we'll return it. And if for some reason someone got into Authenticate and there was no user with that user's name, that shouldn't happen. I just have a return false here for safety, for security. So all of this relies on users being registered, and that came up in add user. So you can see here for add user, when they registered, what we would do, we'd take in their username and password, we'd make sure they have one. Then, because we will be displaying usernames on the screen, we don't want to create we don't want to create a way of doing HTML injection. There's a funny story about this. So another colleague in the department, Alan Hunt, some of you might know him if you took 199 last semester. He and I worked together in developing this course, CSE 404. And for that course, we actually have had some master's students develop a website that we use to track information. The students who developed that website did a very good job of coming up with a website, doing everything pretty well. The one thing they forgot to think about is if someone gave themselves a username that included an HTML injection attack. Now, the trick was this only would ever be displayed on that person's computer. So it was never displayed on anybody else's computer, on any other account, which is why they didn't think about it. But it does display on this student who created that account, their screen. One of the students who used this immediately used an alert function. This is a JavaScript function that just pops up a window. It's really annoying, hence it being an alert. And actually added that to his name. It did not get checked. It did not get escaped like this. And it meant whenever he logged in, he got this alert popping up, which was really annoying for him. We have since fixed it. The point being, if you get a username, you want to make sure when you're dealing with usernames, either you can restrict them from using certain characters. You can try to do some sort of filtering like that. But remember, that creates a game that we're probably going to lose. The better approach is to simply say, okay, here's what we're going to do. I'm going to do this real quick. What we're going to do is have them just automatically escape it out. And so that way they can still type in whatever they want, but the result is safe. So if their username is not the safe username, what I'm going to say is I'm just going to fail it. I don't want to have to deal with this all the time. I don't want to make a mistake where I forget to escape it one time. So this is a way sort of filtering, but not entirely. I'm really just checking that the safe name works. If the username already exists, we'll give them an error. And then what we're going to do is note we're not storing their password, but we're storing their password after it has been salted. So just to show you how this works, that's what I'm going to do. I'm actually going to restart this. I'm going to print out the password originally. Now I'm going to restart it real quick. And it's going to take a little bit because I'm actually generating the keys each time. For reasons I'll show you in a second. And generating 2 sets of keys takes a long time. So if I register something, I'm just going to do it in this window right now. So I'm going to register, I'll register Sarah, give her a password of, we'll do 1, 2, 3, 4, 5. And if we click register, right, I can't actually, the hashed password is not a string, but a series of bytes. So let's restart this one more time. The wonderful things you learn doing this online. Come on. There we go. So if we register, we'll do Sarah again. 1, 2, 3, 4, 5. You can see that when we hash it, we get this very, very, very different result. And that's part of the idea, right? We want to be able to make sure that it's not guessable. If we make another account, name it after my daughter, and give her the exact same password, you can see that the result is similar, but it's not exactly the same. So it begins with this $2b, $12, but then note that the rest of this is actually very different. And this is the benefit of salting those passwords. What it means is that even if someone were to hack this system, and honestly, it wouldn't be that hard to hack this system, it's totally public, and get our database, look through the password file, they'd have no way of being able to actually get back at those original passwords. All they could find is these hashes, and in order to try to figure out what the original value was, they'd have to go through and actually try to defeat the hash function, which wouldn't work. The hash functions are going to be very, very secure. So you can sort of see how this salting and hashing works, part of the benefit. So now if we try to log in, now I'll actually reopen this tab. And actually before I log in, I'm going to do something. Suppose that we wanted to cheat. I can just do it here. And just go to the app itself. Just go to the page that has all of the advanced stuff on it directly. Now, right now I have it. Darn it. Right now I have all my cookies, so I can actually get rid of that. If I go to storage, you can see I've got 2 cookies here, one with my username, one with my token. So let's reload this. And you can see it's not going to like it very much. If we now go back here, right, I log in. You can see part of what we're doing and part of what we need to do in order to stay logged in is use these cookies, create these session cookies. So the fact that it says session, what that means is as soon as I close my browser, these will go away. They won't go away until I close my browser. They're not secure. You can see when they were last accessed. And just as importantly, we can see the value. Now, one of them, username, is pretty obvious. And I could try to change that. I'm not going to. We're going to actually use that later on when they try to access something. The other part here is this token. This is what we're doing to make sure that the person is who they say they are. So for instance, if I change this to Sarah, and note that because this is my computer, I can change that at any point, and reload this page, it's going to eventually get angry with me, maybe not immediately. Why is it not getting angry with me if I try to do this? It's not allowing me to review the page because it doesn't match. So when I try to do this review, it's actually going to give me an real complaint. So I'm going to switch back. See what's going on here. Insert rating is missing. Insert rating is missing. I didn't even change the ratings file. Apparently I did. So that's how this part is going to work. So let's see what happens where we authenticate. We're going to load up the app. It's going to get set up. Note that setup is just going to display that beginning. We're going to get the username, get the element, go from there. Oh, wait, the other thing that authentication does, right? So when we log in, we get the login attempt. We see that it works. You can see now I have 3 different people in my user file. Go back to main for login. After we log in, what you see is that we're going to check, was the person authenticated? If they were, we're going to use the bottle library and we're going to set those cookies you just saw me do. So the first one is username. And so the first argument in set cookie is the name of the cookie. Cookies are actually just key value pairs like before. So we'll set the cookie of username to be whatever their username was. Then we're going to establish a magic token, right? And what that magic token is this is not always the best approach, but what we're going to do is just take their username and sign it. And signing is another trick to for how we can use this encryption library. Literally what we're doing to sign it is we're just taking the username and we're encrypting it with that second set of keys. Now the trick being that at any point in time, what we can also then do is decrypt that cookie and we should get their username back. And we're going to use this as a way of checking out who they are. Another way we could go about this is by encrypting some sort of secret or often just random text and storing that value in our database. And so every time someone accesses a page, what's going to happen is they will end up sending all of these cookies. And so we can check that that random token we generated matches what's in our database. 2 different ways of going about it. So, where's the login? It was down here. Now, as I try to get back to where the login is. So in the login, we'll set the cookie. We'll then set that token cookie to the encrypted value, send it back. Then what we can do is check to see, when we do anything, we're going to use is get username. And all get username is going to do is get that token, the token cookie. We know that that's encrypted. If not, we're going to decrypt it. And we're going to say that's their username. Now, this would be one way of doing it. This is a first step. But of course, if you remember, this was still vulnerable. When I changed the name of the cookie from Matthew to Sarah, actually, if I do this, you can see what'll happen. Sarah will come up there. If I reloaded this page. Now, if I try to post something, actually, I can't remember. Yeah, right now, it's actually going to crash. The reason it crashes, I was trying to remember if you heard, I was trying to remember if I had reloaded the page. I haven't reloaded the page, but I have restarted the web app. So when it tries to decrypt that secret token, it does not work. And the reason it does not work is because when it tries to decrypt it, it was encrypted using the old set of keys. So it doesn't work anymore. It can't decrypt it using one set of keys when it was encrypted using a different one. So let me try this again. Log in again. I'm going to log in as me because I can remember that password. So now I have my token. My token will have changed. If we look, you can see that that token is very different because now we're using a different password to encrypt it. I'm going to again change my name to Sarah. And what I'm going to do is I'm going to do a review. We'll say, no, I'll make fun of her. I'm going to suppose that for the sake of argument, my wife is a huge fan of Despacito. To be fair, I would never marry anybody who's a huge fan of Despacito, but that's besides the point. When I do this, you're going to see that now I added to each review who the user was. And you can see that even though I've tried to hack the system and say my name is Sarah and give that username, note that the actual value it's displaying here does not change. It still says that I am me because it's using that decrypted token. And in fact, if we wanted to make this stronger, what we could do is this. Right? We could actually do a comparison. So in addition to that token, we could get the username. And then we can say if they're the same, so if someone hasn't hacked the system, if they're different, then we know someone's trying to hack our system and we're just going to reject it. So let me restart it now. And I really should, for these purposes, I really should change how I'm generating these keys each time so I don't have to wait, but it's okay for the moment. Note, I'm not really showing you much of what's going on in ratings. I will post a link to this. Honestly, there's no difference in the rate in how we're doing any of the ratings. The only thing that's interesting and new is this process of creating an account. So I'll log in as myself again. M. Hertz. Oh yeah. If anybody would like to hack this out, by the way, my account on this system, for what it's worth, is password. Open this up in a new tab. So I got to log in again because the session cookie went away. So now if I try to change this, and fill in a rating, it's simply going to reject it. It's going to give me, it's probably going to give me, it's just going to reject it because it doesn't want to allow me to do it. It knows that those things are different. So now I have a check in there to make sure that the person is who they actually say they are. And the only way you could fake this would be, we could change these keys around, but in addition to the username, I'd also need to know how to encrypt that username using our secret set of keys. So that's going to be very difficult. If I switch my username back, now you can see that's going to go through. So this is a way that we can actually really secure our system. We can actually make sure that everything is being done properly by checking this username, by checking everything else. And again, if I try to, if I would try to go to something directly, right now I don't think I'd do anything about it. No, right now I still have the cookie again. What I could do is automatically redirect it if I don't have one of those cookies back to the main page. The bigger thing is in order for this to work, I need to have these accounts, right? So we just are using, authentication and setting these cookies to be able to verify who people are and that they are who they say they are. So hopefully this shows you an idea, gives you an idea of how we go about this. We talk about it sort of in theory in the lecture. You can see practice in here. In order for all of this to work, of course, we do need to use those cookies. We do need to have some way of tracking who they are because, as we talk about in the lecture videos, in the HTTP standard, in the web standard, HTTPS standard, it has no way of tracking one thing to the next. If it weren't for cookies, each time you request a page, each time you request a song, anytime you do anything, you would get the same result. Note that when you post something, so here we have post, what we can do is get the username, and so when I was trying to rate the song, it was able to get my username because when I send that post request, it also includes all the cookies. Every time we connect, it includes all of those cookies. So while this system is starting to get pretty big, it's trying to get pretty large, in reality, there isn't a huge amount that's new here. All that we're doing that's different is, frankly, we added a little bit of this work for these cookies, the login process, and that's it. If we wanted, what we could do is, by building it up little by little, we never have to think about the whole big, huge system, right? The ratings.py file virtually is unchanged. I added one little thing, which is simply that a rating now also has a username. It's one field. A lot of my functions over here in help HTML helpers and Ajax don't change. The code that did change now is just in my web server, and even there, for searching, nothing changed. For rating a song, we just make sure that the user is who they say they are. For adding a song, the same idea. So hopefully this gives you an idea of how we can use authentication in our systems, how we can build up these bigger systems by going little by little. Do you guys have any questions? Okay, I don't see any questions. I think that was hopefully long enough. If you do have questions, I will have office hours at about 4:15. They'll be open. I do have somebody who's coming at 4. So I'd be happy to answer them then. If you haven't noticed, howdy. I still can't believe you used the word howdy. You're the person who had a Despacito too, aren't you? I'm just kidding. I have no idea who did. We didn't have it. If you do have questions, remember the project part 4 is due today at 6 p.m. If you look, I know the TAs are trying to stay busy, that their office hours have been crazy. Piazza has been exploding. Apparently, I have had 14 students post or respond to posts while I've been talking to all of you. I've been trying to keep up with Piazza as much as I can. Hopefully we can get you help that way. Other than that, thank you all. Have a good weekend. Stay safe. Stay healthy. Next week, what we're going to be doing is introducing a new problem and really talking through how to make a game. So we're looking at writing games as a web app. So actually doing some really interesting graphics and starting to think about those sorts of issues. Again, trying to tie everything we've talked about this semester together. Also, just so you all know, the plan is by the beginning of Monday, I do intend to have some sample questions. They'll be posted to UB Learns because that's where you're going to be taking the final exam. I'll make an announcement in Piazza, but there'll be sample questions to give you an idea of sort of the breadth of material that could appear on the final exam and the types of questions that will appear on the final exam. This isn't going to be exactly like the final exam. The actual questions on the final, the text, the content might change around a little bit, but it'll give you a good idea of what you should be studying, how you should expect questions to occur. So thank you all. Like I said, stay safe, stay healthy. Make sure you have at least a little bit of fun this weekend, and I will talk to you all later.